Video 3, scene 7A, take 1. Is that good for you, James?
Yep, got it.
David, we talk about this concept of guaranteeing quality of experience for mission critical or business critical applications. It's a big word to say guarantee.
Sure.
It's a big statement, a big phrase. How do we get to the point where we can say, we guarantee?
That's a great question. I mean, this is very much a function of application control. And application control at its heart is about controlling those applications to then ensure that you achieve whatever the objective is. If you then set certain applications aside and you declare them as having a particular criticality to the business, then the whole design of this solution is about, right, okay, we will guarantee that we can achieve that objective. That is a big word, guarantee. It's an absolute statement. How does it do it? Well, the system as a whole uses collective intelligence. These are the appliances work together to analyze the prospect of congestion occurring at a particular site. And just before congestion occurs, control kicks in. And what control will do is to constrain, using quality of service mechanisms, the less important applications and groups of applications, and by so doing, freeing up resource for those groups of applications that have a particular criticality to the business. I mean, the key point here is this application control, it's always on, but it kicks in other words, constrains the less important groups of applications, freeing up resource for the more business critical applications just before congestion occurs. Because, let's be honest, like most systems out there, they tend to react to the advent of congestion. Well, then it's too late. How can you say a statement saying, I guarantee a quality of experience for business critical applications if you're already experiencing congestion? Because
it's too late then.
It's too late. It's too late.
So if you use a traffic analogy, it's like if you can see the pattern of traffic building up, if you can see that it gets beyond X amount of cars per hour, at that point you put in a traffic officer or you change the light system or whatever to ensure that it doesn't actually end up constraining the traffic.
That's a great analogy, but where application control, if you draw a metaphor, if you like, to variable speed limits on the freeway or the motorway, but that affects all traffic, all types of traffic.
Understood, yeah.
But with application control, it's like having a more sophisticated form of variable speed limits by saying those groups of traffic, you're constrained to 30 kilometers an hour, whereas those groups, because it's an ambulance or it's police or it's emergency services, hey, fill your boots.
Or the president, right? Or the president runs and they go into these lanes irrespective of the traffic.
Absolutely. So it's you get more granular control. It's a more sophisticated approach.
That's nice.
And it works. And that's why we can proudly use the term, we guarantee a quality of experience sufficient to make sure those business critical applications keep a smile on the users' faces.
Which is then also the reason why we have to tag applications according to the criticality, because if everything was critical, then nothing is critical, right?
Yeah, I'd be guarded about using the term tag. We don't modify the actual packets, but we do group applications into, the clue's in the name, into application groups. And application groups are effectively an embodiment of the policy that you're going to apply to those applications that are part of that group.
Brilliant. Great stuff.
Video 3, chat 1, take 2.
So we talk about this cloud application database, and you mentioned how it can identify, over 5,000 applications, cloud applications, of course. What I'm particularly interested in knowing is how long does it take before it identifies an application as being Office 365 or Adobe or one of those 5,000? Is it a long process? Is it minutes? can you expand on that?
Sure. I mean, remember, this is a cloud application database. So we're talking about applications delivered from the cloud. We're talking SaaS applications. And those applications, of course, are being delivered from servers located in data centers around the world. Yeah. At the end of the day, how do you identify a server?
IP
address or fully qualified domain name. And that's effectively what this cloud application database is. It's a directory of hundreds of thousands of IP addresses and fully qualified domain names of all the potential sources of those SaaS applications. So, to come back to your specific question, how long does it take to identify? Hey, hi Isaac.
At the handshake.
At the handshake.
Oh, clever.
Absolutely.
So from the very first packet, when you're
from that SYN,
you know the application knows.
SYN,
That's really
SYN-ACK,
clever.
ACK. Yeah. From that SYN, that first SYN packet, I've got your IP address.
So I know exactly. I know what you are, and I know if there's a prioritization.
Exactly.
I know exactly where I give you that prioritization.
Yeah.
That's really clever.
It is.
I really like that.
And it's part of the visibility story. Remember, all of this depends on good visibility. And this provides real quick...
You can't see it, you can't measure it. You can't see it, you can't adjust it, you can't do anything.
You can't control it, you can't secure it, and so forth. It's a very, very powerful asset and part of the portfolio of ExtremeCloud SD-WAN.
And that application is constantly being updated. I mean, if Adobe were to move to different servers, whatever, it would pick it up.
Or typically add more servers.
Of course. They correct. As they roll out in different regions and things like that, it just updates it, and you have that information.
Yeah, it's constantly
I really
updated.
like that. That's really clever. Yeah. Very clever. I like it.
Good stuff.
Video 3, chat 2, take 1.
Earlier you spoke about SSL optimization, and when you did, my antennas went up immediately. It's like, SSL optimization. Can you unpack that a little bit? I know SSL is it's a rabbit hole we don't want to go down, but what are we talking about when we talk about SSL optimization?
We're talking about SSL, Secure Sockets Layer, and its successor, TLS, Transport Layer Security. They're encrypted flows. Just park that one. And we're talking optimization. What do we mean by optimization? What we're really talking about there is compression. So hang on, we're talking about compressing encrypted flows? That's impossible.
That's what got my antennas up.
Absolutely. By the nature of encryption, you are randomizing the payload, so you don't have repeating patterns that normally a compression algorithm would exploit and say, oh, I've got repeating patterns, let's just send that pattern once with some kind of signature to the destination, and then in future, all I need to do is send the signatures, which are much smaller bits of data, and then the receiver can use those signatures to recreate those patterns. But we can't do that with encrypted traffic because we don't have repeated patterns.
Sure.
So we're basically trying to do the impossible. Now, the way SSL optimization works is by ostensibly using the ExtremeCloud SD-WAN appliance as a proxy. That proxy will take that encrypted flow, decrypt it, compress it, and then re-encrypt and send the flow on its way. So effectively, the appliance is acting as a proxy, or in layman's terms, as a man in the middle, but a good man in the middle.
Yeah. Okay.
Obviously, it's got to use a certificate.
Okay. Yeah.
And that certificate effectively is a clone of the certificate being used between the web client and the web server that's serving up that SSL or TLS stream.
Wow, that's clever.
Yeah, it is clever. A lot of the back end is managing those certificates. And that's what these appliances are really good at. Because, of course, it's not done at the appliance level, it's done centrally at the orchestrator level.
And So these the appliances are doing this. Are they doing it at wire speed? Are they introducing latency into
Yes.
into this whole thing?
We call them SOPs in the business, SOPs.
SOPs.
SSL Optimization proxies, and it's about 5 milliseconds of delay they introduce.
So if you're doing a lot of SSL traffic, you still get the benefits of
massive
this
benefit.
this optimization.
Be honest.
For 5 milliseconds, you can live with that.
If there's no benefit, why bother?
Yeah.
It's a really good feature. And it's supported by any appliances that are capable of doing compression.
Gotcha. That's neat. Thanks for that. I was wondering, and I thought that that answer really explains what it is. Very good. Excellent.
Good stuff.
Video 3, chat 3, take 1.
This is the welcome series, and we talk to an audience that might not be very technical.
Sure.
And there's a lot of terms, and you've explained a lot of the terms as we go through some of the acronyms and stuff. But the word flow, you've often spoken about in these 3 episodes, this concept of flow. Can you just unpack that a little bit?
Sure.
I know you're a good instructor and you've already spoken about it, but I feel that we could just open that up a little bit more. What we talk about when we're talking about flow.
You can think of a flow, we use it a lot, you're right, Isaac, this term flow, and much of around the whole SD-WAN solution from Extreme is around controlling these flows, particularly those that have a certain business criticality. So what is meant by a flow? Well, it's happening now. It's a conversation between a source and a destination. We have a flow here. It's bidirectional. I'm speaking to you, you're speaking to me. So effectively what's happening here are 2 flows effectively in sync. Now, one definition then is a flow is simply a conversation. You could also argue it's a session. Sometimes we use that term session. The technical definition is it's identified by 5 tuples. Source address, destination address, source port, destination port, and then transport. Whether it's
UDP or TCP?
Well done. Whether it's a TCP-based, connection-orientated flow, or UDP, which is connectionless flow. And I know you've covered those protocols on previous Welcome Series sessions.
So it's if I'm watching a streaming movie, it's UTP, right? The content is coming down. It could be TCP as well. A live broadcast could be all of that. If I'm establishing and connecting to a mission critical app or business critical app like Salesforce or so, that's a flow, right?
Yes.
I'm connecting to a session, I'm doing work. All of that is termed flows.
Yes, it's one way of describing that.
Okay.
So it's flows of data flowing from
Backwards
source to destination. Yeah,
Okay.
Indeed.
Cool. That makes it really easy to understand.
Good.
Thank you.
Pleasure.
Video 3, chat 4, take 1.
David, you were talking about reporting, and I want to bring up the topic of real time in reporting. Okay, so when we're talking about reporting, IT manager, network administrator, network engineer, obviously need to have their finger on the pulse of activities of what's happening, right?
Sure.
And of course, we gather information, we look at information over different periods of time, but this term real time, can you explain what that means in the concept of what we've been covering about SD-WAN when we're doing reports, for example, real time? Is it real time as in real time? Are we aggregating data over a period of time so that we can look at it by second per se? Can you just elaborate a little bit on that? I think that needs to be expanded as well a little bit more.
Well, the SD-WAN solution is pretty much near real time in that it's taking samples, analyzing, and then acting on those samples each and every second. I mean, that's
as close to real time as what we need.
Absolutely. But very often when it's then reporting, it will aggregate that information, which is effectively being sampled every second, and then present it with maybe a level of resolution of about maybe every minute. Because
Okay.
rather than constantly
Yeah, otherwise
sending
it's just massive amounts of
too
traffic going. Okay, I get
absolutely,
that.
and it would be kind of defeat the object. However, you're right. As an engineer, you might be wanting to troubleshoot a particular issue, get to the root cause of that issue, and you say, well, you know, I want something with a resolution that's better than every minute, thank you very much. I'd like to see it every second. Well, there is a particular feature that you can select within the application monitoring dashboard. Pick a flow that you want to analyze.
So that could be from a particular branch,
Absolutely.
a particular branch to HQ, for example.
Yeah, carrying a particular application. And you have some concerns maybe over that. And you want a finer grain resolution than every minute. What you can do is you can select that flow in the application monitoring dashboard part of the solution and select for that flow real-time graphs. And this is by exception. You select it, click on that feature, up pops a set of graphs where the resolution can be every second. And you can have up to 4 of those real-time graphs presented simultaneously.
Okay. Okay, all right. So, and of course that must be because it's pretty heavy to be able to look at data like that on a per second basis. But you've got 4, so you could do 4 sites if you wanted to.
You could do 4 flows.
4 flows. Okay.
4 flows.
Okay. Think of that. So-
Each flow could be in a different site, if you
Okay.
want to, or they could be 4 flows of just one site. It's your choice.
Okay.
But you have that facility. That's what we're saying.
So it's doing that. It's doing that anyway in the background. It's aggregating it. It's pushing it up so that you can get the reporting. But if you had the need, you can pull it up and look at it on a per second basis.
Yeah, which is pretty much real
Okay,
time.
I understand. Yeah, that is real time for a network administrator. You know, that's your thing. And can you then? Can you save that? Can you save that as a report?
You can export those real-time graphs and, you know, for further analysis down the line.
And can you save it as like a template? So next time, if you had that, you instead of going in and saying I want to create the real-time report for this, you just bring it up and it pops up.
Well, that's a great question. In fact, you've got a default set of graphs that will appear when you select real-time graphs. You've got graphs pertaining to the LAN, graphs pertaining to the WAN, an overview set of graphs, and also specific to, for example, throughput and good put, as we say, which are all the good packets that go from a source to a destination. So you've got some really, really well thought out set of graphs that suit, for example, root cause analysis that I mentioned earlier, which is, to be honest, a typical reason why you might select real-time graphs.
Yeah.
Yeah.
Excellent. I get that. It's always interesting, this term about real time, right?
Sure.
So it's good to know. Yes, it does, but it aggregates it so that you can still see that 1 second increment over a period of time, historical period of time. Correct. But you can see it in real time if you want. Excellent.
Yeah, I just mentioned that generally the application monitoring dashboard provides a finer grained resolution anyway than the reporting database, which has the same information, but that presents it in a more coarse resolution. 5 minutes, you know, up to a year, you know, of historic data can be presented through the reporting database, whereas the application monitoring dashboard, it's more about giving you information in the present. So it tends to be more finely grained, and you can take that to extreme by selecting individual flows and choosing real-time graphs where you get the resolution right down to every second.
Yeah. That really covers
it
covers every use case for a network engineer. Brilliant. Great. Thank you.
Pleasure.
Video 3, chat 5, take 1.
We've just been talking about reporting. We've been talking about the real time and all of that. But one of the things that I noticed was you spoke earlier about storing data, that the data can be stored for up to 13 months, right? Now, within Extreme, I'm hearing a lot more this talk about, data is gold. Data is the new currency. So, and that's not a new concept, right? I mean, Google has been mining data for years and years, and look the business that they've built. But you have all of this data coming from your SD-WAN solution, all of this data being aggregated and stored. Where's the value for our customers? They've made the adjustments, they've made the flows, they're getting the benefits of SD-WAN, but all this data is sitting in log files. Where's the value? How can they utilize, that gold that's sitting there? How do they unlock the power of that?
It's all dependent on what they're trying to achieve as a goal. There may be a rapidly expanding business, opening up new branches, or they maybe want to be a little bit more agile and adaptable, so they're keen to roll out new applications that might be better able to engage more effectively with their customer base or their supplier base, or the whole from supplier to customer story. To be able to do that, you've got a plan, you've got a forecast. And the great benefit, one of the key benefits of this historic data that you can display beautifully in these sets of reports is things like capacity planning, being able to plan for the future. What if analysis? What if you roll out this new application? What is the impact on our existing applications, on our existing flows? What would be the likely outcome? And not have to rely on heavy traffic engineering to do this, which is the traditional tool set that many businesses have to use. They have the visibility again, captured as historic data sets, displayed with elegance using the reporting feature of the ExtremeCloud SD-WAN solution. And there they have the ability to forecast. I mean, the old phrase, forecasting is difficult, particularly of the future, is a quote I love. But when you've got a historic data set, you learn a lot from the past.
Yeah.
And that's the real value.
So
and that's just one use case. That's just one use case. There could be many other use cases.
Yeah.
But
so if you're opening a new branch, let's say you're a franchise and you're opening a new branch.
Sure.
You're recording all of this information, right?
Yep.
And that gives you a reference of what the data traffic looked like at that point in time.
Correct.
And that means when you open up another branch, you don't have to guess. You can go and look at historical data. Yes, it might not be exactly the same,
sure,
but you can certainly get a good overview, because if you've opened up various branches, you'll see patterns emerge from that, and that'll help you. That's where the gold is. That's where the intelligence is.
Yeah, and another example is you want to roll out a new application, as I say, to be more responsive to your customer base, but you worry about the impact that new application will have on your existing infrastructure. But again, by looking at this historic data set, this gold, as you say, you're able to better judge the impact without relying on extensive traffic engineering techniques. So you could roll out that application instead of the usual time to roll out a new app might take 6 months. Roll it out in half the time. That makes you more agile, more adaptable, get out there and beat the competition.
Excellent. Brilliant. Thank you.
Pleasure. The key here, if I can just say, Isaac, the key here is this control kicks in just before congestion occurs.
It's fine, you can, in a minute, carry on from where you are.
That was your bloody coffee.
It just fell.
Yeah.
No, it wasn't. You look guilty then.
No, it wasn't.
It was Cindy. She brought in the coffee without sugar.
It's reflecting light.
How did that happen?
It'll be alright, I think.
Magic.
Something about the magic or something.
Something about the magic. Yeah.